Thank you so much for your love and support. Once again, we are back with another question. A deployment name memory demo. The default name is space with following specification. 4 pods should be running, but few pods is not running. Troubleshoot and fix the issue. A fair enough memory CPU request to set. Limit should be exactly double the request, and the fair overhead should be there and can scale down deployment to 0. The pod must run successfully without hitting a memory scheduling constant. So, if you are not familiar with this request and limit, one beautiful video is there in our playlist. I recommend you to watch so that this concept is very clear to you. But just briefing about the things: memory, CPU. One CPU equal to 1000 M and 1024 Ki equal to 1 mi and 1024 mi equal to 1 gi. So we'll start. For any pod to run, it require memory and CPU. So what is a request? Means it's the minimum required to run the pod. If suppose request 100 m and suppose node 01 has 200 m available, so this pod will run. If I will run another pod with 100 m, then this pod will run. If will run another pod with 1 m, this pod will not run and goes to pending state. Okay, similar like the memory when request is set, but in limit request set to anything, means you can limit set to this also. Limit set to means request limit can be over committed, but this should be within the requirement. If I'll go to the page and I'll describe node 01. Why node 01? Because control plane node has a 10, so it will not use for scheduling of things. So here you will find that 875, and so only 875 can be handled. And here you see that memory is this. This is the request can be entertained, but here one sentence is written. Limits may be over 100%. That is over committed. So it could be anything, but resources this should not be more than 100%. So a deployment memory. So I'll deploy one. A deployment memory demo is in the default namespace. So get deployment. You will find memory demo is running, and when we get pod, so you'll find that 3 is running but 1 is in pending state. So what I will do, I'll just describe node 01. So I'll go up. I'll make this little small so you can see. So in describe node, you will get from here this status is there. So you will get rows label. It is not of our use. It is not of our use. Then we'll get to this. It is also not of our use. Here two things is mentioned. Okay. This is ephemeral containers and this. Our concern is of this. So this KI and this CPU, this memory and CPU is of our use. So I'll copy it, save it, and then this part is of our use. Okay. So I'll copy it from here, and this is of our use. So you are seeing here 3 pods is running. So 3 pod is scheduled and CPU is only this one. Okay. So I'm being here little slow so that you can understand the logic well. So here 1 means it's a 1000. 1 is 1000 M, and this memory is you have to convert it to MI. But no, it is converted to MI. So what is the CPU? This copy and echo dollar this and here v space divide symbol, then 1024. So it is 1868. So it's 1868 MI. I'm writing only this part because this is the unit. Okay. Now here is 250 250 is 750 and memory is 1500. Okay, and this is 875, means this is already occupied because this include this is this also. So what we left with is 125 M. Okay, so at the time of you should take this, and I want 10% overhead also. So what this include? Overhead should be 10%, 15%, 20%. According to the means it varies. Generally, I will take it as 10%. Then this one 25M cube system 25, 50 and 250. Sorry, 25, 50 and 50. And then this 7 pods. This is 250, 250, 250, and one is not, it's in pending. Okay, so let it be, means we'll take the, means it is pending. Now this will not consider because we have to edit it, have to adjust these two things, we have to adjust. So from this 10%, so eco dollar means you can do my calculation. I will do calculation in that terminal. We simply take the logic. Overhead equal to 1868. I'll come to the next page because here a little space is left. So 1168 and this is 875. So only 125 is, it is of no use because it shows total capacity or request there. So 1168 memory 1000 M, sorry, 1868 MI and CPU 1000 overhead 10%. So it's a, we'll calculate it, it's 100. And then cube system, it's a 125. So it's left with 775. Okay, now CPU and it's memory is 1868. So 10% 186. I'll consider as 190. Okay, so and cube system is 100 mi. So we'll minus 100 also. So 1868 minus 190 minus 100 equal to 1578. I'll take round figure, means this is 1578. 4 pod to be run. So I'll take it 700 and I'll take it 1005. I will divide it by 4. So here 1500 divided by 4 equal to 375. I'll take memory as 375 and 700 divided by 4. I'll this take it 175. This is about the request and then limit. It is said that it should be double. So 175 into 2, 350 and 375 into 2, 750. This you have to edit. So let's check if this is it, then our pod will work or not. So just I'll make it little okay. So let's get to work. Now I'll calculate for CPU. So echo dollar, I'll make control L. Okay, for CPU 1000. Okay, overhead is echo dollar 1000. Okay. It's an integer. So 110 divided by 100. Why this is giving error? Let me check. Error token is cross 0 1 10%. Oh, sorry, this 100. This is 100 and now well overhead is 100 and now that echo cube utilized cube system utilization is echo dollar. It's for integer calculation, so don't add float in this. 100 is 25 plus 50 and space is there 50 plus 50. Oh no, 125. So echo dollar 1000 minus 100 minus 125. Oh shit, I have to correct again. Oh no, this is, so we left with 775. So I'll control L that available 775. So echo, I'll take it is 700 for the safer side, or you can take this 775 also, but I'll make it 700 so that 4 pod. Sorry, I'm doing typo mistake every time because I'm watching in second screen and my keyboard is in first screen. 775 is a 175. So memory we have to assign 175. And similarly, you can do calculation for the memory and you will get it is 375. So I will edit it and check whether the things are working or not. First get deployment apps and my memory demo, and I need to take a backup YAML. Uh, backup l hyphen question number 7 dot eml. Sorry for a little sound issue. Now we'll edit. We have taken the backup of deployment apps. So now I'm editing these values. K via vi k deployment memory demo. So if I scroll down, there is init container also. Oh, this is a good. This is going to be tough now. Don't worry, we'll escape it now. If init container is there, you know, you can define same for both. For main container and init container, you can define same. For scheduling, whatever be the greater, that taken into account, because this init is always says that in it. So there is no extra means required. If this init is 400, then scheduler take this 400 into account. Okay. And main container is 300, no worries. Okay. If init is 300, init container take 300 and main container take 400, then this taken in when account taken into account for scheduling. So whatever the max it will take, and but we are keeping it same, then no worries. For another container, for something, if side container are there or two container are there which is parallelly running, then you have to divide this by number of containers. Suppose it's a 2 container, then divide by 2. If it is a 3 container, then divided by 3. If it is a 4 container, then divided by 4. So it is a init container. We not worry for this both of the thing, request and sorry, both memory and this you can divide it by. You no need to divide it by the number of container. But if it's the case of sidecar container or parallel container, means those container are running in parallel with the main container, then you will need to divide that request to equal or means something like that, means so that this whole can be consumed by 2. Otherwise you will left no resources, because there will this is mean there is a 175 and this take 175 main, this take 175 side, this take 175 main, this 175 175. So you need more resources. Okay, so now so no worries for this init container. There is no issue. We can edit, and file is very big. So request search request, and there you can edit. It's a 175 and it's a 375. If it is asked 375, then it's a 750. Limit is not mentioned, but if limit is not mentioned, but in question it's given. So if it is in question, it is not asked, then don't worry. But it is asked in question, then you need to change that to 350 m and memory equal to 750 mi. For the init container also you need to change the same thing, 50. Sorry, first we have to scale it down. Okay, then we have to change it. So k scale deployment memory gap down replicas to 0. Then you have to edit, you have to make changes. This changes 350 request and all things, and then wgif, and then a get deployment, so it's a 0. Now scale once again to 4. So k get deployment app, k get demo, k get pods. So all is running. So first you have to make it 0, otherwise it won't work, because it is already, it's a rollout strategy. So you have to first make it 0, and then you have to increase replicas. But how do you know this is the 2 container or not? I means how many container is not? So we have taken backup also. So cat bc and then grep, and then you have to image. So you will find 2 images are there. 2 images means 2 containers. Okay, you can take -a E5. So hyphen E4. So you'll find container this and this. There are two container. So you need to divide it by 2. If there is one container, no worries. If there is, here is two container, but you want to check whether it is the init or not. So instead of E5, E10. So here you will find init container and this second container. First is init container. Sorry, it's a container, then init container. Okay. Or you can only use grep container -i. So here you find container and init container. But in side car container, you won't get the information about these two. So both you can execute. First you can execute with the image containers and then you can execute with the image. So you are damn sure that two containers are present. So you need to, for init there is no worry, but for another container you need to divide it by 2. So control L and k describe deployment my memory demo. So here you will find this two container is running and with the required memory and required things. And if you will describe node node 01. So here you'll find that this limit is exceeded, because here message is also there that this could be overcommitted, but this should not go beyond 100%. This become a little longer video, but we'll do more video like this. Part 3 will